So far we've done derivatives, which was finding from an original equation what the rate of change or slope would be. What we're now doing is antiderivatives, so we're starting with the rate of change and we're trying to get back to what the original equation was. In order to do this, where we begin is by learning the reverse power rule. So it used to be that if we had y equals x to the n, dy dx equaled n x to the n minus 1. What we now want to do is take this derivative equation and get back to the original. The way that we're going to do it is if we start with dy dx equals x to the n. When we integrate, y, instead of subtracting 1 from the power, we're going to take the power as it is now and add 1 to it. Then instead of multiplying by the power that was there, we're going to divide by the power that the new equation is. So basically, if we start at x to the n, it's going to become x to the n plus 1 divided by n plus 1. First question on this class worksheet asks you to find if dy dx equals 4, what does y equal? So really what I'm doing is I'm integrating 4 dx. When I do that, it becomes 4x plus c. Two things going on here. We originally had no power of x. The x appears as x to the first when we go from a constant to integrating to where it would get back to. So this really isn't using the power rule as much as it's using, we know that if we take the derivative of something with a single power of x, the x disappears. So if we integrate something without the x reappears. The key part of this lesson is this idea of plus c. Plus c basically means I can have any number being added or subtracted to it, and it wouldn't have changed what the slope is. When we had something that had a derivative of 4, all that meant is that the slope of the line was 4. We don't know where the intercept of the line is. So it could have been that it goes right through the origin with a slope of 4. It could have been that it's down here with a slope of 4, up here with a slope of 4. There's infinitely many lines with a slope of 4 that all would have the derivative dy dx equals 4. What this plus c does is it tells us the slope is 4, so the equation is 4x, but we're not sure what the intercept is. That plus c could be a plus 5, which would start the line there. Plus c also could be a negative number. It could be, let's say, a negative 4 that would start the line down there. So whenever we integrate something, we have to add that plus c to say that if we took a derivative, that constant part would go to 0, so we really can't know what it was unless we're given an initial condition. When I go to try b, dy dx equals 4x, what I'm really doing is I'm integrating 4x dx. I can use my new power rule that says, take the power that's currently on x1, add 1 to that power, so it's going to become x to the second power. Divide by the new power, 2. Really, I also have to worry about this 4, but since it's a constant, I can just kind of pretend it's here, that I don't have to integrate with it, so that when I integrate, I get x squared over 2, and then the 4 is being multiplied by it. If I finish this out, 4 divided by 2 gives me 2, so I'd get 2x squared. Then I always need to remember that plus c. When I go to do the third one, dy dx equals 4x cubed. Here again, I'm taking the integral with the constant outside of x cubed dx. This is going to become x to the n it started out with, so x to the 3. We're going to add 1 to that. That's why it becomes x to the 4th. We're going to divide by the new power, which is also 4. In this case, this 4 in front and this 4 in bottom cancel out, and I'm just left with x to the 4th plus c. For the final one in this first part, it starts off as negative 4 over x squared. I can still bring that negative 4 out front, but instead of integrating 1 over x squared, I'm going to call it x to the negative 2. The negative 4 stays out front. When I apply my power rule, I'm adding 1 to a negative 2. I'm not making it more negative. When I add 1 to a negative number, it goes to negative 1 instead of negative 3. So this becomes x to the negative 2 plus 1 divided by negative 2 plus 1. If I resolve, this negative 4 stays out front. This x to the negative 2 plus 1 becomes x to the negative 1. On bottom, it's being divided by negative 1. So my final answer, this negative and this negative combine to give me a positive 4. This x, which was negative 1 on the top, becomes positive 1 on the bottom. And then it's still plus c.